Hello, everybody, and welcome to today's webinar from CrateDB. This is a live event, so if you're watching this on YouTube or you're watching us on LinkedIn, you'll be able to comment and I'll be able to see those. So if you're out there and you feel like sharing anything with us, then just let us know what you're up to, why you might be here, what you're interested in, or maybe just where you are. So I see already we have somebody on LinkedIn from Austria. So hello, Austria. I should introduce myself. My name is Simon Prickett. I'm the developer relations person at CrateDB. So I handle technical storytelling, developer advocacy, teaching people about the product. So today's session is going to be a mix of two things, really. We're going to look at some slides, and I'll talk about how CrateDB is applicable to issues and challenges faced by the renewable energy sector. And then we'll look at an actual small demonstration application that has a nice maps front end that you can take home yourself and play with because it's in GitHub, and you can do it entirely in the CrateDB free cloud tier. So we have two things to look at over the course of what should be a 45-minute presentation. So what I'm going to do now is just go straight ahead. But again, feel free to comment. I can see your comments and I'll be able to respond. So I'll try and make sure to take time to do that. So a bit of scene setting. So I don't work in the renewable energy sector. I do have some background in IoT and controlling buildings to manage their electricity use, but it's a very broad sector. So I did a bit of research and found, what might be the challenges in the renewable energy sector. And we're going to start with, in common with a lot of other things, big data management and scalability. So as the energy sources have diversified, and also consumers have changed, there's a lot more data in the system now regarding generation of electricity and consumption, but also storage of it and the health of individual devices that are involved in that. So, a wind turbine, for example, generates electricity, but it also generates huge streams of data about its own health, when it might need servicing, temperatures of it, the environment that it's operating in, etc. And these data streams become finer and finer grained. So things that might originally have been at a sort of hourly level might now be at a half-hourly level, or 15 minutes or a minute, and it's only going to get further and further so there'll be more and more data. And there's more things taking part in, let's say, the electricity market for now. So we're moving from powering vehicles from combustion engines to electric power. That's largely starting with fleets of public service vehicles or publicly owned vehicles, but increasingly private cars too. So the other thing that I noticed was, data quality and availability of the data. So what do we mean by that? Getting the most from a sort of investment in renewable generation or a renewable tariff, if you are a consumer, requires quite a lot of optimization of data and a highly performant system, because some of this is you need good data to have insights and to make decisions, and you need that data to be available quickly. This can be a problem where you're operating in conditions where networks can be unreliable, they're in harsh environments, but also you need the ability to forecast. So poor data quality can affect your ability to forecast, to maintain a stable grid or whatever it is you're operating, and importantly, to predict and schedule maintenance, which is part of maintaining that stability. You also want to be able to analyze your data in a timely fashion. If you can receive all of your data really, really quickly and reliably, and it's good quality data, but you have quite a large time lag between it arriving and the ability to do anything meaningful with it, then the value of that data is greatly diminished. So data integration and interoperability. We said that there's vast quantities of data coming from sensors and IoT devices, turbines, battery storage, solar panels. These often come from different manufacturers that have different formats or protocols associated with them, which means that integrating all of this into a coherent platform is complex. You might not have a database that can store all of these types of data or query them, or you might end up building a sort of spaghetti architecture to pull some data items from one place, some from another, and amalgamate them in application code. And again, standards and APIs generally help with this. This is an evolving area. So as these evolve, things will improve. But we're in a time where these are generally disparate data sources and formats. And then finally, I sort of touched on it at the start with big data. A lot of the data is coming from the customer now. So customers traditionally in energy were consumers. So they would buy energy and they would turn the light on or do something with it, run the manufacturing process. Customers now could be considered as what we would call prosumers. So both producers and consumers in the same system. So customers with solar panels or an electric car or factories with load shedding capabilities could be considered both a consumer of electrical output and a producer of it at the same time. And to get the most out of this behavior, again, you need quality data and you need to be able to receive it extremely quickly and turn it around so that the customer can make their own decisions in a timely fashion with the most up-to-date data. So these are 4 things that I noted as challenges for the sector. These map fairly well onto what we see at CrateDB as typical data analysis challenges in the modern data world. So you have limits on scalability of your solution. Generally, you need insights that are available in real time, but quite often there's issues with indexing and storing data and making it available to query. The volume of that data is rising exponentially. So as I was saying, the more turbines you put out there, the more data you'll have, the more people you win over to your renewable energy solution, the more consumers you'll have who also want more data and produce it. So the data gets produced at both ends of the system. Whilst as an operator, you would also want to increase your productivity over time. People are looking to AI for that now. So looking at things like planning maintenance through sort of vector similarity searches of if we see this sort of behavior in, say, a turbine, what does that mean? And how can we spot that and head it off and fix it before problems happen so we don't get downtime. And then finally, planning and operational costs. All of this stuff costs money. So what we find is folks are generally looking for things that can, in the data storage world, help them out with these problems, but maintain a relatively low footprint so that the cost of storing the data is generally reasonably cheap. Storage is quite commoditized. The cost of running software to do aggregations and processing over it is wildly variable. So what is CrateDB? Probably a good time to introduce that. So I try not to read from slides, but CrateDB is a hyperfast open source database for real-time analytics, AI, and hybrid search. What do we mean by that? We mean that CrateDB is a database that is optimized for analytics type use cases. Works extremely well in cases where there is a high ingest of data required. The data is a mix of structured, semi-structured, or unstructured, and you don't necessarily know what sort of queries you want to do over it. So how do we go about enabling success in this area? What we do is we have a product that combines SQL, so something you already know, and a flexible schema that you might associate with other types of database that aren't necessarily SQL and table-based. And we also have a distributed architecture for scale. So you can ingest data very, very quickly. You can ingest that across a cluster, and you can also query it across the cluster with all of the nodes in the cluster working together to ensure performance. So let's have a look at this in a little bit more detail. So CrateDB stores all sorts of different data types in one place, in one database. Everything lives in a table, so something you're familiar with from the relational world. But inside that table, you can have columns that contain all sorts of different data types. So you might have a time series, something that's indexed by timestamp. You might have geospatial data. It could be GeoJSON or well-known text format, two standards that are widely adopted. You might have document or semi-structured JSON data. So within a column in a table, you can store, for example, a JSON document, and you can tell CrateDB, yeah, I know what the structure of that is. Here's what it looks like. Or you can leave that undefined or semi-defined. And when you put data in there, the database will figure out what you've put in there, figure out the right data types for it, and index everything for you. We also support full text search. So if you want to do keyword search, and vector similarity search. So more important if you are searching through things that aren't necessarily textual, or you're doing a semantic textual search. But if you've got, for example, a series of data values from, say, wind turbines or something, and you know what the outcome after the end of those events were, say after a certain pattern, the turbine usually fails of something, then you can compare that to streams of data from other turbines and figure out which ones are heading in that direction and head that problem off. So tables sound kind of rigid. In fact, CrateDB operates a dynamic schema in two ways. So with JSON document data, as I already said, you can put that in a column in the table, and you can evolve the schema of that as you go. You can either just drop data in there, or specify a full schema for what it looks like, or a partial one. And you can also tell us not to index some things, but we will index everything by default. The dynamic schema also applies to table columns. So you can define a table in a way that if you put more data in there, so a wider record in there than originally was there, the database will just extend the table, add new values for the subsequent records that have it. Obviously, existing ones will remain null, and it will begin to index that as well. So this is important for analytics, because analytics is fed by multiple different systems. You're constantly going to be adding new systems, or maybe you change a sensor or a machine type and it sends different parameters. And the ability to just keep putting it all in the same place and have the schema adapt to it automatically is extremely useful. And the indexing everything is extremely useful because you don't know the nature of the queries necessarily that will happen when you store the data. So in a traditional database, you would design the data storage and the indexes around the query patterns. With this, you can be a lot more flexible. So on top of that, we have the ability to do some level of programming over the result set. So when you're selecting things, we have the ability to write user-defined functions that live in the database in JavaScript, and those essentially transform data. For ingestion, we also support pulling data in from other data sources. So think of CrateDB as a sort of sidecar companion database for analytics here. So you're not going to replace your existing system of record for some of these things with a CrateDB instance, but you are going to use it for insights and, for example, AI model tuning, building dashboards, alerting customers, predictive maintenance, etc. So we support change data control and foreign data wrappers, so we can reach into other databases and pull data into queries in CrateDB and also replicate it. So how does CrateDB run? As I said before, it's a distributed execution engine. It is optimized for a high volume of concurrent reads and writes. So quite often with database clusters, you have to make a decision about, is this a write mostly or a read mostly operation? We're optimized for both of those things going on at the same time. And the aim is to minimize the time between something hitting the database and it being available to query. So we index everything in that, and that indexing happens in the distributed cluster. And we use the right storage for the right data type. So for some things, we might use an inverted index, other things, columnar storage. Then where is CrateDB available? Well, we operate a cloud. We're in the public cloud as well, so you can deploy CrateDB to AWS, Google Cloud, Azure. We also support on-premises and edge, so small devices. And you can build a hybrid solution that goes from something like an edge at, say, I don't know, out at a wind farm or something, to on-premises at, say, a larger data center or a factory or something that you have to monitor, and then have a cloud that acts as an aggregation of all of those. So the product supports all of that. The big bar down the right, the good news is we do all of this through native SQL. So you can insert, update, query data through something that you're already familiar with. Doesn't matter what type of data it is or what type of query you're performing over it. So if you're doing just a straight, time series, select some value where some other value is greater than a number, and the time period is between this timestamp and that timestamp, that's SQL. If you're doing a full text search, so find everything in a log that refers to a certain keyword or synonyms for that keyword, also SQL, similarly vector similarity, and also geospatial. And the real power here comes in the ability to mix and match those sort of different data types in different SQL clauses. So you might ask a question of a time series sort of data and ask it only in the context of a certain geospatial area that you can apply to the query, all in one place without having to do these queries separately, pull them together and iterate over the results, perhaps in code. So over here on the left, you can see all of the sorts of data sources that you might find providing data to CrateDB. For this audience, probably telemetry data, maintenance data, and some external data. So what's going on in the energy market is something that you need to be on top of, and also what's going on with the weather. How does it get in there? We obviously support, you could just write code that writes SQL statements, but we also support larger and more standard interfaces. So for example, you can stream data in through Kafka. We have change data control and the foreign data wrapper, as I said before. But also, for example, connecting Crate to an MQTT broker or other similar data broker is very simple. Then over there on the right, you're going to want to do something with that data once you have it in the database. Again, we use native SQL for everything, and over here, and it also applies to the input. CrateDB supports the Postgres wire protocol. So this means that if you're using existing tools, so something like Grafana or Power BI, or you're a developer and you're using an existing software stack that you're familiar with, and we'll have an example of that with some .NET code later, then you'll be able to just adopt this fairly simply and use the power of the multi-model database and the query engine, the ability to combine all of this stuff with largely the same tool set that you are already familiar with. So what does that mean at the end of the day? We try and help people get to three things. So hindsight, looking at things that happened in the past, insights, what's going on right now, and then foresight, which is often associated with the machine learning aspects. You want to predict the future. So, based on what we've seen in the past and what we know now, what might the future look like is quite a common thing for, say, vector similarity search. Then I wanted to show a use case very, very quickly. I'm developer relations, so I'm more about the code and how you get into the product yourself, and we'll come to that. But we have a use case here, and I will just put up the URL for that. So if you want to go and check out the webpage for that and read more details. But for example, we have worked with a company, Gantner Instruments, and the University of Cyprus. So they have a smart renewable energy grid on their campus. And the management of this is optimized by AI, and the models for that were trained on data captured in CrateDB. So the data is actually captured in real time, and it's available for analysis and query in near real time due to our high ingestion rate and optimize index everything approach. And they use this to power both dashboards, so looking at the state of things now, and other downstream systems, as well as running the AI models to predict need and maintenance and so forth. So this system uses CrateDB both in the cloud for the majority of the data and on the edge for like a local working set of recent data. So components in it can mix real-time data with trends and aggregations from a longer time period. Okay. I'm going to switch gears a little bit now and turn the banner off there. So for the rest of the presentation, we're going to focus on an example that you might have seen me talk about on this YouTube channel before. We have captured some data from the UK's offshore wind farms and sort of got it as an example data set. What I'm going to show today is how you can go and play with a .NET application that loads this data into a CrateDB instance, and then you can query it. But I've also got a sample application that has a maps front end that shows how easy it is to get started with fairly familiar tools and just start building something with data in CrateDB. So I'm going to move ahead from that. I'm just quickly checking. I think we're all good in the chat. But if you have any questions or just shout outs for who you are and where you are and what brought you here, then I'd love to hear from you. So our data comes from wind farms in the United Kingdom, specifically the offshore ones. There's 45 of these, and wind is an increasingly, it's quite a windy place, the United Kingdom. We're actually expecting quite a major weather event in the next 24 hours here. And wind, at the time that I happened to pull this data, was about 22% of the overall generation mix on average. So there's a lot of wind power. We have 45 locations, and those are growing both in numbers and in turbines. So what data do we have? So we have data from the Crown Estate, who manages all of this stuff. And they have data about where the wind farms are. So we have that as a geo position, a singular location. What you see here is the geo shape. So that's actually North Hoyle Wind Farm. It is not a particularly interesting shape, but we also have the data for where the turbines are within it. So you can see them nicely lined up in rows. And then how do we model this stuff in CrateDB? So I said CrateDB is a database that puts everything into tables, even though we're essentially a multi-model, not only SQL database. We support all sorts of different data types, but we express that through SQL. So here I'm creating a table for the wind farms themselves. We've got some fields like you might expect, an ID and a name that are just text. We've got a description field, which is a free text description of what, information about the wind farm's history and construction. And we're indexing that with full text. So you could do keyword-based search queries on that. And then we've got a vector representation of the same text that I generated through an OpenAI text model. So that we might use, we're not going to do that today, but we might use that for semantic versions of the keyword search. And we can also combine the two together in what's called a hybrid search. We then got that location, which is a singular geo point. And the boundaries field is a geo shape. So that can be any sort of GeoJSON or WKT data that describes the overall shape of the wind farm. And we can use that in queries as a clause. So we could say which wind farms are within this polygon that we've drawn or intersect with this polygon we've drawn, and use that to limit our queries. And we've also got a turbines object in there. So I was saying that we can store JSON document type data. So inside the turbines object there, I said it's a dynamic object, so I can put anything in there and the database will adapt to that. But I've also described some fields that I know are going to be in there. So we have a model for the turbines, what make and model they are. The location is an array. And as you can see, we can build deeper and deeper types. So I have an array of geo points here, so a lat long for every single turbine. And then just a convenience for a number of how many there are. So you can see here that we build these tables very easily. SQL not particularly new to many people, but we could keep building out, either a very nested object inside the turbines column there if we know more about it, or we could just insert values that are more nested than that, and the database will go ahead and dynamically extend the schema and begin to index everything. So we have another sort of data as well. So we have data about the wind farms, and then we have a more time series data about power generation at the wind farms. So once an hour, each farm sends a relatively small record that says, this is my ID, and this is a timestamp of which hour this data's for. And we get the output of the wind farm. I think that's in megawatts. And then we get the percentage of what it's theoretically capable of. So at this point, the top one there was operating at 29% of its theoretical output. So we get these over and over again. It's a never-ending stream of data. It's a time series. And how we model that in CrateDB is also a table. So I've created another table for wind farm output. Couple of different things here. So what we've done is this data could run forever. Storage doesn't run forever, and sometimes we want to offline or delete things, and we also want to optimize queries. So what we've got here is a table is partitioned by a timestamp that I've had the database create on insert. So the timestamp doesn't exist in the data, and that just is the timestamp of the first of whatever month the data's for, and then we're partitioning the table by that month so that you've got essentially a virtual table that's made up of a lot of partitions, but it looks like a singular table to queries. It speeds up querying because if we know that data in the query isn't in a given month, we don't need to go look in that partition, and also allows us to offline or delete data when we're done with it without affecting other partitions or doing costly rebuilds. So those are our tables. What we're going to do now is actually show some code. So I've talked quite a lot. I'm going to show some .NET code, and I'm not going to focus too much on the front end of this, which you can see operating in a GIF over here, but we will obviously take a look at it. So I am going to switch to Google, the web browser here, and let's bring this up. So I've got some example code. Let's make this a bit bigger. This is actually a project that you can try for yourself at home or in the office or wherever you are. So let's get the URL for that if you want to do so, because everything you need is here. So if you want to try this out for yourself, you can do. What you'll need is this URL, a CrateDB database that will either be in the cloud, which you can get for free, or we've included, there's a Docker Compose file in there. So you could, if you're familiar with Docker, you could run the database locally and run it there. What we're going to do is I've gone ahead and created a database already, but I need to create the tables in it. So I'm going to just take these create table statements that we had in our slides and just paste them into, this is a completely empty CrateDB database. Make that a little bit bigger as well. There we go. So we've created a table and there's nothing in it at the minute. So let's just go back to here and create the other table. And then I want to show you how one of the ways we can get a lot of data into a CrateDB database quickly. So we've got two tables now, they're completely empty. And what we've done is made the data set available at a public URL. And what you can do is tell CrateDB to load the data from that. It's JSON objects that look like the table schema. So when we do that, you'll see we've loaded 45 records. That's each of the wind farms. No errors. That's what we want to see. And then similarly, let's have a go with the wind farm output. There's a substantially greater amount of this. So that's actually in a gzip format. So we're going to pull that in gzip. The cluster will unzip it and load everything. And that's going to take a couple of seconds. But there we go. We've now got 75,825 records. And if we just really quickly go over here, stay over here, and run a query, let's just get everything from the wind farms table. You can see that our table has all the fields that were in our schema. They're now all populated. Description's quite a long one here. So let's just get past that. And let's actually select something a little bit more ID name turbines, for example. Let's select that. So here you can see that I've got this JSON document that is inside one field. So it's inside turbines, and the schema of this is dynamic. So we could change this or update it or just put any old JSON in, the database will adapt to it. And I can also select things. So if I just want the locations of the turbines, which is itself an array, then I've now got that. If I just want something else, I can just specify the field name here, and we can go select these arbitrarily deep. So we can select things from anywhere in the JSON document and combine it in clauses with anything else that's in that table, but also join it with other tables. So let me go ahead and switch to some code now. So this is the GitHub repository that I got a lot of autocomplete going on. The GitHub repository that I have at the location below. It consists of two pieces. There's a JavaScript front end and there's a back end application that aims to show you how easy it is to connect to CrateDB and make some queries with it. And there's three versions of that. Well, actually, there's two at the minute. There's Python and C#.NET. So I'm using the C# one here. The Python implementation's in a folder called Python that contains exactly the same thing, but as a Flask application. And then I'm shortly about to add a Node.js one. I just need to check that in and push it. So there will be a JavaScript version of this. The way this works is we've built a simple API. And from developer perspective, the aim here is to try and point out that things, this might be a new database to you, but the infrastructure that you use is already pretty familiar. So I said earlier that CrateDB uses the Postgres wire protocol. That means we can use Postgres clients by and large to connect to it. So if you're a .NET developer and you've used Postgres, we're using MPG SQL, which is something that you are probably familiar with already. And then we're building a fairly standard .NET API. And I have an MPG SQL source here that I just use a connection string for CrateDB, which we go and have a look at what that means. In the .NET world, it's just basically a case of providing some information about where the database lives. So if this was in the cloud, it would have a different host and port and a username and an actual password. I'm running just locally in Docker today, so I don't have any of that. It's just 127.0.0.1. And what you'll see is if we want to, for example, pull data from CrateDB, we just run a standard SQL command like you would for any other database using the MPG SQL driver. So we're running a select query here. This one doesn't happen to have any parameters. And then when we get a result set back, we can treat the result set like we would as if it had come from any other database. So the aim here is to demonstrate familiarity. Let me just turn that off. There we go. Free up some space down the bottom of the screen. And What do we get back from that? Well, we get a results set. And as you can see here, in a single results set from a single table in CrateDB, we've got some simple types, we've got some strings, but we've also got something more complicated. So we've got an MPG SQL point, so the geo point, and then we've got JSON documents, and these map then into C#, and we can just treat them like we would anything else that we pull from a database. So some queries here have parameters. So here we're passing in a wind farm ID from the front end. And again, we just pass that as a parameter like you normally would, and put a placeholder for it in the SQL query. So nothing, again, hugely unexpected. I'm trying to convey here that there is a lot of familiarity and ease of adoption. So if you're building an application with CrateDB, then you're already working with things that, well, you're using things that you've already invested time in and working with. So we have a few endpoints here that do different things. So some of them run aggregation queries, and some of them run SQL window queries. So they will pull, this one, for example, pulls the cumulative output of a wind farm for the day per hour. So it's one thing to look at the SQL, and I would really encourage you to go get this project from GitHub and try it out for yourself. But the best thing to do is, if we go ahead here and just do .NET run, then hopefully live demos, we should get a front end at 5213 that we can interact with. So I'll bring back the browser. So here we go. So we have .NET backend that basically just ran a SQL query in CrateDB to get some data, and it rendered that on the map there. So we used the location of the wind farms to show an individual marker for where they actually are. And then we click through this. We made another call to the backend, which made another call to CrateDB, and ran that SQL window function for what day, what was the output for each hour of the day. This data set that I've got is kind of a static one. It stopped on the 28th of October last year. But if this was live streaming data coming in, then the fast ingest rate and the index everything approach would mean that these queries would still be extremely fast, but using your live data. So what we've got is you can move around the map and click and see some level of things. But also, as we zoom in, what I've built this to do is switch to more data from CrateDB. So we switch out the markers to the polygon shapes of the map. These, because they're stored in GeoJSON in the database, map almost one-to-one to what the maps library in the front end expects. So the code for showing one of these is extremely simple. It's basically take the value you got from the database and add it to the GeoJSON layer here on the map, which, if you're familiar with leaflet maps, is an extremely simple operation. So at this level, I can click on one of these and basically run some different SQL queries. So we've now got a maximum output per day for this wind farm for the last 10 days. Again, sort of aggregation CrateDB excels that with real-time data. And then finally, what I can do if I zoom in a little bit more is, remember we had that array of turbine objects, and inside those were all of the turbine positions. You can see that we can zoom in and actually see the layout of the wind farm. So the data set that I've got here is a little bit limited. There's nothing to click through to here because we don't have the data for the individual turbines, which would be great. But in a real world system, you could imagine that this would then allow you to zoom in and look at what's going on in the near recent past with some of the turbines. The reason why a product like CrateDB would be excellent for this sort of thing is you don't know the patterns that people are going to want to query this data in. They're discovering things about it. You want it to be near real time, so as up-to-date data as possible. And you don't necessarily know what the format is going to be for any great length of time. We might start installing different turbines that have more data parameters. We might want to take advantage of those. So that's the small demo here. I'd say if you go back to, if you are a developer and you want to try this out for yourself, then I strongly suggest you do so. So if you go to GitHub here and grab that, and I'll make sure that that's in the notes on both LinkedIn and the YouTube description as well afterwards. So let's switch back to our slides here. So that was my little demo. And I always try and have these sessions with one thing that you can take away. So one thing to remember. And I'm going to cheat today, and there's actually two. So one of those is that you can get the code for this project, and that's where you get the code for. The other one is, remember, cratedb.com/academy. So if you found this session interesting and you're intrigued with what a multi-model distributed SQL database can do for your search and analytics, then go along to cratedb.com/academy. We have free online courses that you can educate yourself as to how the product works. And you can also earn a certificate of completion that you can share as a qualification on LinkedIn. So that was about everything I had today. The other thing that I would encourage people to do is come find us in our community. So we have community.cratedb.com. It's a discourse forum. But also you can find me in other communities. So if you want to chat about anything CrateDB, or you want to, you're trying this project out yourself and you have questions about it, then you can reach me on LinkedIn, on X, on GitHub. I am fairly easy to find and will welcome your questions. So yeah, I'm just going to check the comments here today, and I think we're okay. So with that said, I said this will be a 45-minute live stream. It looks like it's going to be a 43-minute live stream. So I will give you 2 minutes back of your evening, and I hope to see you online at an event or something. Please do try the project, and please do let me know how you get on with it. Thanks very much.